Good morning. Today we are making our video for packet number 3, which is due on November 4th, which is next week, Tuesday. On our first page, we have to place the digits 2, 4, 5, and 7 in the boxes below to make the equation true. So we need to find an equivalent fraction, that a big fraction using double-digit numbers that equals 3/6 if we were to simplify it down. So put those 4 numbers, you can only use each number once, put them in order. So you could do something like 24 and 57, but does that simplify down to 3/6? Spoiler, it does not. So you need to guess and check other ways to equal a fraction that is equivalent to 3/6. On our second page, Henry used half of his flour to make blueberry muffins and half of the remaining flour to make tofu muffins. He has 1.5 cups of flour left. How much flour did he start with? For word problems like this, I love to use my bar model. So I say this is how much flour altogether that Henry used. He used half of it to make blueberry muffins. He used half of the remaining to make tofu. And this is what he's left with, which is 1.5 cups of flour. We need to find out how much flour he had right from the start. So if we know this is half and this is half, and we know half is 1.5 cups, you should be able to fill in what the missing numbers would be to be able to add them all up to find the total number of cups of flour. Our next page is our 5-card challenge. We need to add all of, or use orders of operation. It is different numbers than what we have in, I think it's different numbers. My packet might have, are these the numbers that somebody have their pre-algebra packet out? Are these the correct numbers?
Yeah.
Okay,
Yep.
these are correct numbers, so my packet has an old version. When we have an ace, there is 1 heart, so it is equal to 1. You need to come up with different equations to equal that 1. Be very careful when you are making your numbers. Some people make our 9s and our 4s very similar. If I cannot discern the difference between a 9 and a 4, it will count as the same number, and there is only 1 9, 1 4, so you will not get credit for that. Make your numbers look how they're supposed to look. 9, 4, make it obvious if it's a 9 or a 4. Okay, be careful with that. Remember, order of operations does matter. You can use parentheses if you need to. For our logic page, pre-algebra completes the table for the number of red blocks and total blocks in each figure. So let's fill in what we do now. Figure 1 has 1 red, 0 blue, 0 purple, 1 total. Then figure 2 has 1 red. I filled in for all of them just because it made it easier for me to find the patterns. You do not have to do the blue and the purple. Like I said, I did it just to make it easier for me to find patterns. Now, filling in that total blocks, I can show us an easy little trick. There are 2. One is to look at how my blocks are increasing each time. To go from 1 to 4, I add 3. To go from 4 to 9, I'm adding 5. To go from 9 to 16, I'm adding 7. I can see a pattern to follow. 3, 5, 7, I know the next time I'm going to add 9. So follow your pattern to complete that column. Or you could come and look and see, what are Mrs. Gambino's favorite numbers? Our pattern blocks. So many times they will show my favorite numbers. I personally love perfect squares. Favorite kind of numbers. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. I can see a pattern using my perfect squares to fill in those total blocks. Okay, see then if you can find patterns for filling in the red. So I helped you with that pattern for the total blocks. See if you can find other patterns. Fill in. You have to do all of the red and all of the total blocks. You can do the whole table if you would like. That's what I did on my answer key, just to keep it simple. We do not have a question, so you do not have to put an answer. You just have to do the red column and the total blocks column. Our next page is our perimeter and area page. For that perimeter, remember you need to fill in any missing side lengths, add up all the sides for the perimeter. For our area, break it into shapes that we know, find the area of the shapes that we know, and add up those areas. Our next page is our net page. So we've been working with rectangular prisms. We need to do a net this time of a triangular prism. So if we look at this, we can see our bottom shape is a rectangle. Then we have 2 more sides of rectangles. And we have our 2 ends that are triangles. Now we have to label all of our sides. The long side of our rectangle is that 14. Fill that in. Our short sides are the 5s. Our triangle has sides of 5s. And that 4.3 is the height. So that is important to note that that 4.3 is the height, because to find the area of our triangle, we do 1/2 of our base times the height. So this is our base is the bottom of the triangle. Our height goes from the base to the tip. And then find the area of our rectangles, which is length times width. So you find those 3 areas, the 2 areas of our triangle. You add all 5 areas up to get your surface area. Our next page, we need to do the volume of that triangular prism. So we know the area of just the triangle is 1/2 times base times height. But it is not just a triangle, it is that full prism. So we also multiply our length. So we have our base, we have our height, and we have our length. And then you take 1/2 of it. So 1/2 times our base, times our height, times our length. Multiply that up to get our volume. And then we have to do our pre-algebra question. The base, width, and height of each of the prism are each increased by 2. What is the surface area of the new figure? So think back to that surface area we did on our previous page. Increase each of those numbers by 2. So when you multiply them together, instead of doing 14 times 5 for that rectangle, it would be 16 times 7. So increase each side length by 2. So when you multiply together, you will get the new surface area. Now we have Pascal's triangle. So it says we are going to find what is in each space. We add the 2 spots above it. So I'm going to get us started out with this. We have a 1 in our first spot. There is nothing next to it, so that's a 0. 0 plus 1 is 1. 1 plus 0 is 1. Coming down here, 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 0 is 1. So we are following that pattern, 0 plus 1, 1 plus 2, 2 plus 1, 1 plus 0, and keep working your way down. So here we would have 0 plus 1 is 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 0 is 1. Just work your way down, adding the 2 on top every time we go. We will be doing lots more work with Pascal's triangle over the year. Then we have our mean, median, and mode page. Remember, first thing we do is we put our numbers in order from least to greatest. To find the mean, we need to add all of our numbers up and divide by how many numbers there are. We have, I believe, 9 numbers. So we add all of our numbers up, divide by 9. That gets us our mean. Another word for mean is the average. So whatever your mean is the average of those numbers. To find the median, you find the middle, and mode is the most, the number that we see the most. Our question is, if there is one test remaining, what is the minimum score the student needs on the test in order to earn the Euclid? That means we need to get our average, our mean, to be 90% of 10 numbers. So right now we have 9 numbers. If we're going to put it at 10 numbers, what do we have to score to get it to be at 90%? At least 90%. So you might have to do a little checking and guessing and checking. But you need to get that to figure out what you must score to get that at 90%. And our last page is our polynomial. So sliding into spots, there are several different answers for this one. So yours might not look the same as a neighbor's, and that's okay. As long as you are not flipping and turning and rotating, just sliding them into place, in all of them fitting perfectly. And that is our video for packet number 3. If you have questions, come and ask me. If you're watching this at home, I hope you are well and hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.